Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on September 5th, 2025, about 3 days ago. The standout claim is a more than 90 times increase in industrial production efficiency for creating interactive 3D worlds while keeping high creative quality. The paper is titled LatticeWorld, a multimodal large language model empowered framework for interactive complex world generation. And as we will see later, the practical speed-up and fidelity are striking. In short, a lightweight large language model plus Unreal Engine 5 turns text and visual hints into large, physics-aware, multi-agent environments with strong scene layout accuracy and visual realism. Alright, Figure 1 showcases what the system actually produces: interactive 3D scenes with agents, terrain, and weather that render in real time. The montage highlights adversarial agents, character navigation, and physically consistent effects, which means objects move and collide as they should under game engine physics. Several panels also show terrain generated from visual hints like height maps, so layout, and assets match user guidance. Together, these examples underline both fidelity and dynamism. Well, Figure 2 shows how user inputs flow through language models into a procedural pipeline that renders interactive 3D worlds. The left block gathers text and an optional height map, which is a grayscale image where brighter pixels mean higher terrain. The center block aligns visual features with tokens, so the layout and configuration stay consistent with prompts. The right block feeds those decoded settings into Unreal Engine, which outputs dynamic scenes with controllable agents. So the table defines the layout alphabet, which maps single letters to asset types, so the language model can output a compact grid that still encodes terrain and objects. This symbolic layout is a 32 by 32 matrix of letters, which the decoder later turns into engine assets. Letters include farmland, buildings, barren lands, grasslands, and roads, and for the wild dataset forests, rocky lands, snow regions, and water. This mapping enables controllable, reproducible layouts because each token has a clear visual meaning. Table 3 compares layout generation quality across models, showing that the proposed approach follows the textual instruction most faithfully. The table presents the instruction, a color legend, and the generated layouts side by side, which makes spatial mistakes obvious. The proposed layout preserves roads, water on the right, forests on the left, and a central farmland, while alternatives collapse structure or oversimplify scenes. This matters because accurate symbolic layouts drive believable 3D worlds downstream. Wrapping up, 2 takeaways stand out. A lightweight language model plus Unreal Engine 5 reliably turns text and simple visuals into accurate layouts that render as interactive, physics-aware worlds, and the production pipeline gains exceed 90 times versus manual workflows. The broader implication is scalable simulation for research and content creation. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.